In this demo design, we'll be going through how to model an existing network from GIS data as a DXF. This is the second video in our underground training series. Link in the description for video 1 if you need a refresher on the underground tools available. Using the basic tools we've learned in video 1, we can model a single feeder from the substation we have in our design. Building on what we had in video 1, we can extend our previous steps to our larger design. We'll go back to the trench tool and place trenches along our design where we see these green lines. You'll see in the properties panel, we can select the default section to go in our trench when we place it. In this case, we'll be mainly using the default 1x1 150 mil conduit for most of our design. So we're just gonna go through our design, click along where our DXF has this shown, and place it along. And add in this additional trench here for across the road, and we'll just have it join to our pillar here. The next thing to do is to take a closer look at our design and change the trench sections where necessary. So if we zoom in on this specific section here, we can sort of see that there are two cables inside this trench, one going further along to the next pillar and one going to this light. So in this case, if we go to any underground tool and we hover over, we can see there's only one slot inside that trench. In this case, we want to go on the trench section tool to change this section to have two slots. In this case, we'll use the preset 3, which is a 2x1 section of 150 mil conduits. We'll simply click here to start the section and click further along to end it. You can see if we place the new section over our existing section, the existing section gets split into two. So as we hover over our trench section, we can see that it starts off with a 1x1, changes to a 2x1, and then eventually goes back to a 1x1. And this enables us to have two slots for our two cables to go into. As we have our trench section set up, we can then use the cable tool to place our pillars and lay our cables. So clicking off our previous pillar, we can extend the network along our trench route and click on the trench wherever we want to change our placement or place a pillar. So going through this, click on this pillar. We're going to select the placement to be placement number 1 in this case, and we'll string it along here. It will go into the default placement. We can click here where there's a pillar and we can select the option to add a pillar. Going further along our design, going up to this last pillar, we're going to add in another pillar at the end. So this is it for our basic design. We have two more things to connect up. We have to connect to this pillar across the street, and we have to connect to this light, which we'll do at a later step. We should use the cable tool to place a pillar on the other side of the road and connect it through as a road crossing to this pillar here. Another thing that we can do is that we can add attachments to streetlights. So we do this by using the pole tool and just placing poles wherever we see them in our design, specifically these streetlight columns here. From there, we can use the cable tool to start our cable at the pillar, run it through this conduit here, but in this case, using placement 2, because this is our second cable that we've put into this trench, running it through and then clicking on the pole. This brings up an option for us to connect it to the pole, effectively making this a UGO. Right-clicking off to stop that, we can also do the same thing here, where we, using the cable tool, click on the pillar, have it route across and connect it to the pole as a UGO. The last thing to do for our design is to add service points. So going back to our service point tool, we're just going to click on each pillar and make sure that the service points are as required. So on this pillar, we have, going back to service point. So on this pillar, we would add two service points, and going to the two pillars at the end of our circuit, we would also add in two service points according to the GIS that we have. So this is it for modeling a single feeder from our sub. We could extract this out to do the other feeders on this sub, but for the single feeder, we have this modeled. The next thing to do in our design is to go through the reports and check some calculations for our design. We can do this by clicking this plus button here to bring up additional tabs. Specifically, we want the voltage drop report here, which allows us to visualize the voltage drop that we have on our circuit. So you'll see here that a lot of parameters are specified for each pillar, but in our case, we care about the voltage drop. So we can see for each pillar, pillar 1 has a 1.17 voltage drop according to its services. We can visualize this better inside our design by using this eye icon here, which helps us visualize the values in our design. Additional parameters such as voltage and current are also available. Another additional report that you may like to view for your design is cable pulls. Again, we go to this plus button right here, and we open the cable tension report. With this cable tension report, we can see a number of results from our cable pull calculations, such as forward tension, reverse tension, or sidewall pressure. In this case, we can visualize the forward pull tension to see how much force would be required to pull the cable through any of the conduits that you see below. So this cable here from the sub to this pillar would require 2.05 kilonewtons to pull. And that does it for our first demo design.